All right, so let's go ahead and find the generalized formula for an ellipse. Okay, so let's go ahead and sketch an ellipse first. Okay, and let's get it established here in the plane in the first quadrant. Okay, without loss of generality, putting this in the first quadrant seemed to make sense. Okay, so there will be a center, and that is going to be given by h comma k, as it typically is. And then we've got these two vertices here. Why don't we call this, well, if this is h, then this would be h plus a comma k. Okay, this here would be h minus a comma k. We then have our sub-vertices. Okay, this would be h comma k plus b. This here would be h comma k minus b. And then we've got our two foci. Okay, here's one and here's one here. Just going to eyeballing this a little bit. And with this focus, we'll call it h minus f for focus, comma k. And this one here we'll call obviously h plus f, comma k. So the definition of an ellipse, okay, is the locus of points, okay, such that the sum of any point on the locus, the sum of the distances rather of the point of locus to two fixed points called foci is a constant. So d1 plus d2 will always equal some constant. We'll call it c. Okay, again, the definition of an ellipse is the locus of points such that any given point in the locus has a sum of distances to fixed points that are, it's a constant. So it doesn't matter where I put this point. I can put this point anywhere on the ellipse. d1 plus d2 will always equal c. Okay. Okay, so this is we're going to call point x, y, and x comma y represents any point on the ellipse. All right. Now, what is this c value? Okay, what is it? Well, let's think about this carefully. Over here, if I have the locus of points, the ellipse that is to say, okay, and I allow the point x comma y to be right here, okay, we realize that these two foci here, okay, one distance, d1, okay, I'm going to just denote that right here, and the other distance, d2, are actually going to add up to 2a. Okay, you see, the distance from the center to the vertex here is a, and the same here, and I'm adding up 2a. d1 plus d2, this is the same thing as d2 right here, I should point out. Okay, d1 plus d2 is equal to 2a. So that's a lot easier to deal with. So let's go ahead and just get that down. Okay. Moreover, if I have the same locus, okay, and I now choose my point x comma y to be up here, okay, with the same, of course, foci. We can see that if I'm designating this point x comma y to be right above, okay, the center, then what I actually have is an isosceles triangle. We know that this is F, and we know this is F. But we know that this plus this has got to be equal to 2a. But we know these are both the same. This is an isosceles triangle. So that means that this is A and this is A. But this right here is B, according to our diagram. Well, that means that F squared plus B squared must equal A squared. That means that F is going to be equal to the square root of A squared minus B squared. So we've established a few interesting observations. Let's now get back to trying to derive the formula, the general formula. So we know that d1 plus d2 is equal to 2a. So what is d1? Well, using the distance formula, it's going to be h minus f minus x all squared plus k minus y all squared. So the square root of all that. Okay, that's going to be the distance d1 plus the distance d2. Okay, and that's going to be h plus f, square root of course. It's going to be h plus f minus x all squared plus k minus y all squared. Okay, so the sum of these two distances is going to have to be equal to 2a. Okay, this is what we're working with so far. Now we're definitely going to want to replace f as the square root of a squared minus b squared. I don't know if we're going to want to do that quite yet, but this is the initial statement here. If I add up these two distances, d1 and d2, I should invariably get 2a. All right, so just checking that over ever so briefly to make sure we don't have any critical errors. We don't. So let's go ahead and square both sides. Well, actually, let's go ahead and subtract one of these radicals over and then square both sides. And why don't we zoom out first before we do that? So here we go. We've got h minus f minus x all squared plus k minus y all squared is equal to 2a minus the square root of h plus f minus x all squared plus k minus y all squared. Okay, checking that carefully. Looks good. Let's now square both sides. Okay, squaring this just gives us the following. H minus f minus x all squared plus k minus y all squared equals, okay, squaring this side, I'm going to get 4a squared minus 4a times the square root of h plus f minus x all squared plus k minus y all squared plus h plus f minus x quantity squared plus k minus y quantity squared. Okay, let's zoom out a step further and then examine that. Okay, looks good. Doesn't seem like we have any major issues here. Clearly we can subtract from both sides the k minus y quantity squared. That's convenient. I would definitely like to square this by subtracting 4a squared from both sides. So why don't we do that? Okay, Well, actually, why don't we expand first? I think expanding is going to be wise because we're going to be able to eliminate a few terms in so doing. So let's expand first. So here we're going to have a lot of terms, but that's okay. We're going to have h squared minus fh minus hx minus fh plus f squared plus fx minus hx plus fx plus x squared. There's your left-hand side. Right-hand side, 4a squared minus 4a square root, h plus f minus x all squared plus k minus y all squared. Okay, let's maybe zoom out one more step so we can squeeze in these, hopefully squeeze in these terms. Plus, okay, here we go, h squared plus fh minus hx plus fh plus f squared minus fx, okay, minus hx minus fx plus x squared. Just squeeze it in. All right. Let's examine that carefully and make sure that we have no errors. Okay. Looking at the left-hand side right now, looks good. Now looking at the right-hand side. Okay, very carefully. F squared minus fx minus hx minus fx plus x squared. Yeah, looks good. Okay, now obviously we're going to want to cancel out a whole bunch of common factors on both sides, either adding the same to both sides or subtracting the same from both sides. Okay, so let's go ahead and do that. You can see that we can subtract x squared from both sides. Okay, we can see that we can subtract h squared from both sides. There's an f squared that can be subtracted from both sides. Okay, and that's gonna do it. Okay, not as many subtractions as I was hoping, but oh, actually, we can add hx to both sides. That's something I just noticed. And we can add another hx to both sides. Okay, so a little better than I originally saw. And actually, it's not so bad at this point because we've got a number of like terms here. For example, here we got negative fh, negative fh, that's going to make negative 2fh. But there's a positive fh here 2 times. So I can subtract 2fh from both sides over here, and it's going to give me negative 4fh. So that's 1 of them, 2 of them, 3 of them, and 4 of them. All right. Here we got fx, another fx, that's 2fx. I can add 2 additional fx's over here to get positive 4fx. Well, that's convenient. I'm glad I decided to expand this first before squaring both sides. Now I simply have 4a squared minus 4a times, of course, the square root of h plus f minus x quantity squared plus k minus y quantity squared over on this side. Okay. Let's check that carefully, make sure no errors exist on the page. Doesn't look like it, but let's be very careful. Okay. Okay, yeah, looks good. Subtracting that. Adding, yep, looks very good. Well, clearly we can divide both sides by 4. Okay, and I'll just go ahead and use the commutative property and write this as fx minus fh over here is equal to, okay, a squared minus a times the square root of h plus f minus x quantity squared plus k minus y all squared. All right. Checking that over carefully. All righty, looks good. Now I think we're going to subtract a squared and then try to square both sides, okay, to try to free up that radicand here. So let's go ahead and subtract a squared from both sides. It's going to give us fx minus fh minus a squared equals negative a times, of course, the square root of h plus f minus x all squared plus k minus y all squared. Okay, squaring both sides, we're going to have here f squared x squared minus f squared hx minus a squared fx minus f squared hx plus f squared h squared plus a squared fh, okay, minus a squared fx plus a squared fh plus a to the fourth. Okay, that's what happens when I square that left-hand side. And squaring the right-hand side, I'm just going to have a squared times, well, I'm just going to go ahead and distribute the a squared to everything in here. Okay, if we're okay with that, it's going to give me h plus f minus x all squared plus a squared times the quantity k minus y all squared. Okay, let's examine that carefully. Make sure there are no errors on the page. Okay. Positive and then positive again. And then negative and then positive and then positive. Yes. Left-hand side looks really good, and the right-hand side also looks good. All right. Well, can we simplify anything over here? We can. We've got a couple of a squared fh terms, and we've got a couple of negative f squared hx terms. Okay. And so, yeah, let's go ahead and simplify, and then of course we're going to also expand the right hand side. Okay, so we have f squared x squared, so that's been accounted for. We've got negative f squared hx minus f squared hx. That's going to give us negative 2 f squared hx. Okay, we've got negative a squared fx and negative a squared fx. That's going to give us negative 2 a squared fx. We've got now an f squared h squared all by itself. And we've got a 2a squared fh. Okay. And then, of course, we've got a to the fourth here. All right. Well, what is it we got over here on the right-hand side? Let's maybe zoom out one step. Okay. I'll be impressed if we can get this all on one visible page here when all is said and done. Let's go ahead and continue. So expanding this and not forgetting to multiply every term by a squared, we're going to have a squared h squared, okay, plus a squared fh, okay, minus a squared hx, okay, plus a squared fh, good, plus a squared f squared, okay, minus a squared fx, okay, minus a squared hx, okay, minus a squared fx, okay, and then plus a squared x squared. Okay, we're going to have to go down right here just ever so briefly. I'm going to keep this actually, I'm going to keep this factored because I can see that this is what I'm looking to actually, part of what I'm looking to derive here. But I am going to go ahead and take a negative 1 out. And this is just going to give me here plus a squared times y minus k all squared. K minus y all squared is the same thing as y minus k all squared. Okay, I can take out a negative 1, negative of the quantity k, the quantity y minus k is exactly k minus y. And the square root of negative 1 is 1. Okay, so that should be clear. Okay, let's examine carefully, making sure we don't have any careless errors on the page. Looks good so far. And now the right-hand side. Okay, looking good so far. Yes. Plus, and then, yep. Everything looks fantastic. Okay, so now we've got a negative a squared fx and a negative a squared fx on this side, and we've got the same right here. So this cancels out with both this and this. Well, that was convenient. That was very convenient. We've also got an a squared fh and an a squared fh, which can cancel out with the 2a squared fh over on the left-hand side. That was helpful. Okay. Anything else that we have here? Doesn't look like it. Okay, doesn't look like it. What we can though do is take and replace f squared, right, with a squared minus b squared. Now we can do this. So here we go. F squared is a squared minus b squared. And then, of course, you have x squared minus 2. And then you have a squared minus b squared hx plus a squared minus b squared times h squared plus a to the fourth, okay, equals a squared h squared minus a squared hx plus a squared times a squared minus b squared minus a squared hx, okay, plus a squared x squared plus a squared times the quantity y minus k all squared. Okay, let's check that very carefully. Again, just taking and replacing f squared with the quantity that we know it is, a squared minus b squared. Let's check that carefully. We got a couple of negative a squared hx terms that should have been combined to make negative 2a squared hx. That's okay. We're going to do that in the next step. Okay. It's looking good. Okay, let's go ahead and now distribute. Here we go. We've got a squared x squared minus b squared x squared minus 2a squared hx plus 2b squared hx plus a squared h squared minus b squared h squared plus a to the fourth. Okay. Over on this side, we have a squared h squared, okay, minus 2a squared hx, okay, plus a to the fourth minus a squared b squared plus a squared x squared, and then of course keeping this factored because I'm sure we're going to like that in the end. Okay. All right, let's see if zooming out, yeah, we can do that one more step. I think we're going to be able to squeeze it in. Okay, let's check our operations. Let's make sure we haven't committed any careless mistakes. Okay. Looks good. Yes, everything looks really good. Well, look at this. We can subtract an a to the fourth from both sides. We can subtract an a squared h squared from both sides. We can add a 2a squared hx to both sides. We can subtract an a squared x squared from both sides. That is very convenient. Okay, so over on this side, we're going to have, and I'll use the commutative property to write, to put the positive value first. So it's going to be 2b squared hx, so we've accounted for that, minus b squared x squared. Okay, you've accounted for that. Minus b squared h squared. Okay, accounted for that. And then here on the right-hand side, we'll write this first. A squared times, of course, the quantity y minus k all squared. And then it's going to be minus a squared b squared. Okay, let's check that. Make sure we have no errors on the page. Looks good to me. Looks good to me. Yeah, we've accounted for that. Okay, so let's now, we're in the final stages of this. Let's go ahead and divide everything through by a squared b squared. Okay, dividing everything through by a squared b squared, I'm going to get the following. We're going to have 2hx over a squared minus x squared over a squared minus h squared over a squared is equal to y minus k quantity squared over b squared minus 1. Okay. So we can now factor, let's actually divide both sides by -1 and take a 1 over a squared out. Okay, so taking a 1 over a squared out, I'm going to get the following. Okay. And let's not forget we are dividing also both sides by -1 in the same step. And I'm going to go ahead and rearrange these. Okay, so this is going to give us here x squared, because we've divided by -1, minus 2hx, because we've divided by -1, plus h squared, since we've divided by -1. Okay, is equal to, again, dividing by -1, both sides. Okay. All right. Let's now add this over to the left-hand side and then realize that this is just x minus h all squared. So we're going to have x minus h all squared divided by a squared plus, since we're adding this over, y minus k all squared over b squared is equal to 1. Okay. And maybe zooming out one more step. Well, that's actually not. Let's zoom in there. I'll just scroll down and then put a box around this here, because this is the statement that we were looking to find all along. There you have it. We have the general formula for an ellipse. Let me know if you have any comments or questions. Hopefully you found this video helpful. We're always open to suggestions for future content. As always, have a great rest of your day and see you in the next video.